All right, so let's get started. First of all, we're going to do some review. So we'll start on page 377. And you guys have told me this was a bit of a challenge. Are there specific problems you want me to cover on this this one on page 277? I'll do one of the lines. Maybe we can do number 2. Any other things you guys want to do specifically?
Number what? Number 6.
Number 6, yeah. What else?
Number 7.
Number 7?
Number 7, yeah.
Yeah. Number 7. All right. Yeah, maybe we'll do number 10 or something like that. All right. So the first one, it's solving it through drawing lines, right?
Yes.
So let's look at number 2. I'm going to. I don't think I have a ruler, so I'm not going to take yours because yours. I ruined yours last time.
It's not a problem.
So you've got this graph, right?
Yeah.
This huge graph across the page. Okay.
You are good at drawing.
They have lines. The board has lines. Very
so
faint lines, so it helps me. Yeah. Otherwise, my lines would be very wavy. All right. So let's see. Number 2. So we have 2 equations, right? Oh, number 2. The first equation is 4x plus 2y equals 10. Okay. And the second one, y equals minus 5x minus 4. Okay. So we need to graph both of these lines. So that's a good practice from before, right? How to graph them. So this line is ready, right? This one we need to put in the format of x equals mx plus b. Right? So first of all, if we look at this, there's a 4, a 2, and a 10. Is there something we can do with that? A 4, a 2, and a 10.
Yes, we divided by 2.
You see, they're all divisible by 2. So we can divide both sides by 2. So I'll just write it here. 4x plus 2y equals 10. Divide both sides by 2. Right?
Yes.
4x divided by 2
2x
is 2x.
plus
2y divided by 2
y
plus y
equals 5.
equals 5. Right? Whenever you see something like that, where you can divide through, it's a good idea to simplify. Just divide both sides by the same number. And now we have y here. So all we need is to get the x onto the other side, right?
Yes.
So how do we do that? How do we get this 2x on here? Another question is, how do I get rid of 2x on this side?
Y is equal to 3x minus 5.
Is what x?
No, 5 equal
Plus minus 5.
We want y by itself, and it's a plus.
Y is equal
Minus
to
2x.
minus 2x.
We need to subtract 2x.
Yes.
Because if we subtract 2x, this will be nothing, and we'll come in here. So we subtract 2x from here, and that'll get rid of this 2x, right? But you have to do it to the other side as well. So now we have y by itself. We'll write minus 2x plus 5. I'm writing it this way because I want it in the format y equals mx plus b. Alright? And the reason I want that is now I know that this is my my y-intercept, right? So I'm going to mark it 1, 2, 3, 4, 5, 6, 7. And here we have minus 1, there, minus 2, minus 3, minus 4, minus 5, minus 6. Okay. So, and I'll do the x's as well. 1, 2, 3, 4, 5, 6, 7. And on this side, minus 1, minus 2, minus 3, minus 4. Let's just start with minus 5 for now, and we can fill in as we need. Alright, so for this equation, this one, y equals minus 5x minus 4. right? So that means it crosses the y-axis where? Remember, the B is where it crosses the y-axis, the y-intercept.
At -4.
At -4 is where it crosses the y-axis. Alright, so that's here. So that means we have a point here. Okay? And then we look, what is the slope of this line? What is M? What is the slope?
The slope is -5.
-5. Okay? So if it's a minus slope, is it going up or is it going down?
Down.
Down. Minus slope goes down, right? And it's -5. So that means if we go across 1, we go down 5. Right? So it's rise over run. So we go down 5 across 1. So we can start here. 1 goes across, and then 1, 2, up, 3, 4, 5. So here, 9 and 1. Okay? And the other way we go, this way we go up 5, right? So 1 and 1, 2, 3, 4, 5. Here, and then we have to draw a line that goes through that. Now this is where I would need a nice ruler. You know what? I will use the remote control. And hopefully I won't get it too messy. Okay. So we go like that. Through these points, right? Okay. So here we have our line. And let's see what the other line is. So what is the B? What is the y-intercept of this equation?
5.
5, right? You see it right here, 5. So that's where it crosses the y-axis. And where does it cross? It crosses here. Right? If x equals 0, if x equals 0, y equals 5. This point here. And what is my slope?
-2.
-2. So is -2, is it going down or up?
Down.
Down, right? And how much? Pardon? 2, right? So if we go across 1, we go down 2. Cross 1, down 2. Cross 1, down 2. Okay, it looks like this one is going further out. So maybe they intersect on the other side.
Yes.
Let's go. Oh, this way we go up to, right? So it looks like we're going to need to go kind of high here, after all. So this line here, 1, 2. And I'm going to do it again, 1, 2, like this. Roll this out. Right? 10, 11, 12 up here. 7, 5, and then maybe up here. 13. Let's see how that works. Right? And then this line is doing 4, right? No, it's 5.
Yes.
So we go across 1 more,
Yes.
and then up to 6, right? Here. Okay. Then we go across 1 more -3, and it goes up to what? 11? Aha! There we go. You see that point?
Yeah.
They're both intersecting here. I'll draw them for you. But we just found a common point, so that's actually the one we're looking for. And this one is like this. There we go. So here's the intersection. Right? And that's 11. Y is 11 and -3. So it's -3, 11. That's how we find them using plotting. It's actually quite a bit of work to plot them. Did you have those huge graphs on your books and you draw with a ruler? How many were able to actually get these? You plotted them. Yeah?
I do it by another way.
Oh, you found the equations a different way?
Yeah, no, I look by the teacher.
By the t-chart. Okay, yeah. No, it's a good way to do it. You did the t-chart. You said, okay, well, if we do x and y, right? We can say x is 0, y equals -4. Then we say x is -2, and y will equal Was it 6? Yeah, y will equal 6. That sort of thing, right? So you kind of, you do that and then you can draw your line using those, because you just find whatever points are on
Yeah,
it.
because still minus 4.
Actually, your way is probably a better way to do it.
Yeah, because 2 is 1, and I start from the 0, and then I just go 1,
1 and 2. Yeah.
Yeah.
All you need is 2. Doing 3 is good. So you're right, you can do x is 1, and then what does y equal? X is 2, what does y equal? And then you can draw the line. Yeah, that's, and you probably wouldn't even need to solve this.
Yeah, and then I get the
Yeah.
same result.
And then you do the line. That's actually, I think that's a better way to do it for this problem because it's quicker. And you just do like x1, y, what does y equal? However, this is good practice for us to see how to draw lines, right? So you have that, but I think your way is probably a better way. However you get to drawing the lines, and you only need 2 points to make a line, then you draw them up and you see where they intersect. But you have to be very careful with these ones because you need to get the ruler exactly straight because it's a very small chart that you have. All right, any questions on this? How to draw them? No? Then we'll do the algebraic way of solving. Well, I guess it's all algebra, but substitution way of solving. So let me take a picture of that. Send it to you guys. Okay, I think we don't need it anymore, right? Okay, so let's look at number 6. What have we got? We have 10x minus y equals minus 1. And y equals 12x. Right. And they want to know, they want us to solve by substitution. So to solve by substitution, we need to find one of these variables by itself, right? Y equals something or x equals something. Unfortunately, with this one, we already start with y equals something, right? So we can say if this is y, there's one point where both of these equations will have the same point as the solution, right? So in that point, if this is y equals 12x, this y equals this y, right? So we could just put whatever y is here in here. So that's what substitution is. So we take 10x minus, instead of y, whatever we have for y here. If it was like a longer equation, we'd put the whole equation in. Right? But here it's just 12x. We put 12x equals minus 1. And now we can solve for x. Right? So here we have 10x minus 12x equals minus 1. What is 10x minus 12x? Minus 2x. Yes. Minus 2x equals minus 1. Right, now we want x by itself. What are we going to do?
Divide by minus 2.
We need to we need to divide by the coefficient here. Right? Divide by minus 2, divide by minus 2. So this becomes 1, we get x by itself.
X equals half.
Yeah, because the negative times the negative, or negative divided by negative, becomes positive. That's right. So x equals 1/2. All right. Now we have x. We can put it back into either of these equations and solve for y. Right. Which one will be easier? Probably this one, right? Yeah. So let's put x back inside there. So we'll do y equals 12 x. And x is 1/2. Okay? So what is 12 times 1/2?
6.
6. So now we have x is 1/2 and y is 6. So that's our solution. 1/2, 6. Or you could do 0.5 if you want. That also would work. Because so half is 0.5.
Yeah.
Okay? And as an example, this is actually one of the reasons probably that Americans like to use the decimal instead of the comma. Because this could be confusing otherwise, right? It could just look like a decimal number in brackets. Okay. Any questions on this? You see what I did? I just said find one of the variables by itself, like as a solution by itself, and put that whole thing in with the variables in the other equation. Then you have just one variable, you can solve for a single variable, and then you put it back to find the first variable. Okay? Let's look at number 7. Where does the line with the equation x minus 2y equals 4 intersect with the line with the equation 6x plus 5x equals 4? Okay, so this is probably the format you will have on the exam for these kind of problems. It'll say where does this line with the equation intersect with the other line. That's telling you need to do it this way. So it's what? It's x minus 2y equals 4. And the other one is
6y
6y
plus 5x
plus 5x
equals 4.
equals 4. Alright. So there's 3 ways we can do this, I'll say. The substitution way is probably going to be the easiest. You can also do the adding and subtracting way I taught you last week, if you're interested. And the third way is you can do the trick where you look at each answer, A, B, C, D, and check that it works. Right? And that way what you would do is you take A and you just see, does it fit both equations? B, does it fit both equations? C, does it fit both equations? Until you find one that does fit both of them. But it could take some time, exactly. So that's one way if you you're not sure how to do this problem, you've forgotten, substitute back in the answers. But to do it this way, I'm going to say let's do it by substitution. And we need to find, is there an equation that looks like it's very close to being written with one variable equals something else?
That's the first one.
The first one. You see this one? We have x minus 2y. So we can easily get the 2y on this side and then we have x equals something. Right? So let's take this equation. And now we have x minus 2y equals 4. We want to get x by itself. Right? So what do we do?
Plus
Yeah.
2y.
Plus 2y equals 4 plus 2y. Right? So now we have x equals 4 plus 2y. Right, so now we have x by itself. Okay? Now we're going to put it back into this equation. Don't put it into this one. If you put it into this one, you're just going to get 0 equals 0.
Yeah.
Okay? Because that's the equation. I remember making this mistake when I was doing this. I would forget that I got this one from here. I'd put it in, I'd solve it, and I'd be like, wait, 0 equals 0. Or 4 equals 4. You'll get something that's like a number equals a number. So put it into the other equation. So here we have 6y, right?
Yes.
Plus 5x. So now we put bracket,
Yes.
whatever x is. 4 plus 2y,
y
close bracket,
equals 4.
equals 4. Okay, and now we have an equation and only one variable, y. So we can solve for y. So you have to simplify it first, right? What is 5 times 4?
20.
That's right, 20. 5
Five
times
plus
2y
Plus 10y
plus 10y
equals
equals 4. Alright, this is a 20. Okay, so first we combine the y's, right?
4.
So we have 16y
Plus 20
plus 20 equals 4. Okay? 16y. Oh wait, you're right, sorry. Let me go through more details. So we need to get y by itself, right?
minus 20.
So we need to get rid of this 20. So we do minus 20. Oops. That's right. Minus 20, minus 20. Right? So then we have 16y. And what is 4 minus 20?
Minus 16.
Minus 16. Ah, it's very convenient. Right?
Yes.
Okay, so what are we going to do here?
Minus 1. Y equals minus 1.
Divide both sides by 16 to get y by itself, right? 16 divided by 16 minus 16 divided by itself is minus 1.
Minus 1.
So y equals minus 1. Nice. Okay. So So now we can come back here and find x, right? So if x, I'll just put a little barrier here, x equals 4 plus 2y. So x equals 4 plus 2, and now we know y.
Times minus 1.
Times minus 1, which equals, what's 2 times minus 1?
Minus 2.
Minus 2. So 4 minus 2 equals 2. Alright, so y is minus 1, x is 2. So we write it, x always first, minus 1. There. That is the point that they intersect, yes. Let's see here, 2 minus 1 is A. So actually we might have gotten lucky with this one if we just tried the options. Because that probably would have been, if we'd just done A, it would have been faster than this. But if it was D, then you would spend a lot of time. Right? And by the way, if you do A, B, and C, and it's not any of them, just put D and keep going. You don't have to solve D. Alright, any questions on this? This is basically the method. I think the GED is teaching you just the substitution method, and I do actually think it's the easier method. But I taught you the other method, and I've given you Khan Academy with the like adding things, if you want to know that method. But for just getting the GED done, I suggest you do the substitution method. I think it's easier than plotting a line as well, unless you have graph paper. Then maybe you could do it. You can feel which one you're happier with. Alright, let's take a picture here. Alright, let's do number 10. Alright. Oh, interesting. It's a bit different. 10 says, which of the following is the equation of a line that intersects y equals 4x plus 2? So y equals 4x plus 2. So it's a bit of a strange question here. Because I might say, well, aren't they basically all going to intersect? Right? Any line will intersect another line. Right? If I draw a line here, right, and here's this line, no matter what this line is here, if it's like this, it'll intersect it eventually, right? Right? Somewhere down here. But there's one kind of line that will not intersect. Okay? And that is a line that's called parallel. Right? They're running the exact same. And the way you can tell if a line is parallel, this has the same shape, right, as this one. Which means this has a slope, a certain slope. This one has the exact same slope. So if they have the same slope, they will not intersect. Right? So if I have, like, for example, you know, it's doing like -1, -1, right? And this one's going through 0. And I go like -1, -1, -1, -1. It's going the same exact way. Right? They'll never cross because they're just going the exact same way. Because they have the same slope. So what that means for this question, what I want to see is, which one of these equations does not have the same slope? Right? Because if it has the same slope, it will be parallel. So if we look at B, B says y equals 4x minus, no, sorry, A. 2y equals 8x plus 2. Well, if we divide that all out, right? A, 2y equals 8x plus 2. We can divide both sides by 2, right? There's 2 all over it. And this is y equals 4x plus 1. So here the slope is 4.
No.
Slope is 4. Not going to work, right? B, we have a slope that's 4 already, right?
Yeah.
So m equals 4. No.
C.
C, what does m equal for C? What is the slope of C?
That's
Minus 4. That is different. So they will intersect.
Yeah.
So it's C. You can check D as well. Let's see D. D says 1 over 2y equals 2x
Minus 7.
minus 7. So to get y by itself, I have to multiply both sides by 2, right?
Yeah.
So times 2, this whole thing times 2, we're going to get 4 again, yeah. Y equals 4x minus 14. Again, m equals 4. So you see here, this one has slope of 4. Slope of 4, slope of 4, slope of 4, slope of minus 4. So which one is different? C.
Minus
C.
C.
So that's how we can see it. It's a bit of it was a bit of a conceptual question, this one. You have to kind of think about it.
C is the answer.
C is the answer, yeah. Therefore, C. Okay, now there are other ways you could do it as well. You could try the substitutionary method with each one. Alright? So let's say we try to do that. Erase this. Let me write on here. Parallel lines never intersect. And that means therefore have the same slope. Okay? Three dots means therefore. Okay? So parallel lines never intersect, therefore they have the same slope. So that's what we're testing here. But we could just do substitution, right? So we have y equals 4x plus 2. For A, we said y equals 4x plus 1, right? So if we substitute here, we can do 4x plus 2 equals 4x plus 1. That's impossible, right? So that doesn't work. We're going to end up with 2 equals 1. So there's no point of intersection. There's no point where these work, okay? We do the same for B, right? B was y equals 4x minus 2. Minus 2. So again, we have 4x minus 2 equals 4x plus 2. Again, it doesn't work. Minus 2 plus 2 is that's nonsense. Alright? C, we did
4x
Y
equals minus 4x
plus 2.
plus 2. Okay, so now we have 4x plus 2 equals minus 4x plus 2. Now here we can do something. We can add 4x to both sides, right? Plus 4x plus 4x. We get 8x plus 2 equals 2. Right? 8x equals 0. Just subtract 2 from both sides. But that's fine. 0 is a legitimate number. Divide by 8. And x equals 0. And if x equals 0, then y equals 4 times 0 plus 2. Y equals 2. Alright, we have an intersection point. So that's actually, then you can stop, you can get C. Right? So therefore C. But if you want, I can do D as well. It'll be the same. We'll basically get to this point where we have 4x plus 2 equals 4x minus 14. And 2 equals minus 14 also doesn't work. So this is the way you could do it without worrying about parallel lines. Do you see that? Any questions on this? When we do geometry, we'll talk about parallel lines. Okay, let's go on to the next page. Take a picture of this first. Are there any specific questions you want to look at for this one?
Yeah, 14.
14? Yeah.
And
What else?
and 13.
13, 4, and 5. Yeah. Any others? 9. Yeah. So this one's patterns. We can start with that. That's a good start. So it's basically the first 9 are kind of patterns, and the first few are just like different patterns. So we just need to solve it. So let's see, number 4 you said? Let's see number 4. Yeah, okay. It says in the function y equals 2x, y equals 2x times 4 plus x minus 2. Okay. If x equals 3, y equals what? This is basically just a substitution. Okay? So the interesting thing is they call them functions. But functions are actually kind of a fancy way of just saying an equation. Right? So it's a function, which means that it's y is a value, x is a, y is a value of x. So however x changes, y changes. But we've already learned this with equations. So you treat it the same way. We basically have an equation here. We can simplify this equation, and then we substitute x, and we find it out. Or we can just straight up substitute x right now. Okay, so let's do that. We'll have y equals 2 times 3, 4 plus 3 minus 2. Okay? And then we have to use our PEMDAS, right? Order of operations. So first, we need to do what's in the brackets. Okay, so what is 4 plus 3?
7.
7. So y is 2 times 3 times 7 minus 2. And now these we can multiply all together. Right? So what's 2 times 3?
6.
And what's 6 times 7?
42.
42. So we have 42 minus 2.
40.
40. Yeah, that's it. That's it. Okay, you just solve, you put x in, and you solve for y. That's how a function is. We'll be talking about it a little bit later today. We see a function is like f of d, and you solve for d. What if d is something, then you can find what the function is. Another way you could have done this is you could have simplified it first. So we could have said, what is 2x times 4?
8.
Equals 8x. What is 2x times x?
2x squared.
It's plus 2x squared minus 2. And then you substitute 3 in, right? So then y equals 8 times 3 is 2 times 3 squared minus 2. Okay? So you can usually do like plus sections together. So 8 times 3 is what?
24.
24. What is 3 squared?
9.
So it's plus 2 times 9 minus 2. Actually, you know what? I'll leave this one. That's alright. So this is now 24. What is 2 times 9?
18 plus
Plus 18 minus 2. So what's 24 plus 18? 42. Minus 2?
40.
40. Same. You can do it either way. Any more questions on this? No? Let's do the next one. Alright, number 5. Each term in the second row is determined by the function y equals 2x minus 1. Right? Minus 1? Yeah. Okay. And then they have this whole chart. Right? It's kind of like the xy table for drawing a line, right? We have here, and they say x and y, and we have a whole bunch of, right? 1, 2, 3, 4, 5, 6, 7. Oh, 55. Dot, dot, dot. And then 12. Right? So this is how a function works. Okay? You have some variable here, usually y, equals some expression of another variable. Right? And then what you're doing is you're saying for every increment of this variable, what does the first one equal? So x is 1, what does y equal? X is 2, what does y equal? It's the same as if I said c equals 2d minus 1, right? Yeah. And for every d, what will c equal? D is maybe the amount, and c is like the total cost or something like that. So what they've done is they've already filled it in for you, right? We have 1, 3, 5, 7, 9, right? And dot, dot, dot. So you can kind of just count if you want on your fingers. Or you can solve for the equation, right? If x equals 12, we solve for y, right?
Yeah.
So we'll do that. Y equals 2 times 12 minus 1. Having the equation of a function of a pattern is great. It's more difficult to find the equation of the pattern, which some of them have, right? So 2 times 12 is 24 minus 1 is 23. Right, so 23. That's what we do. And if you want, you can count it. Right? You do 6 is 11, 7 is 13, 8 is 15, 9 is 17, 10 is 19, 11 is 21, 12 is 23. Right? You could do that. But the easiest thing with these is basically substitution. Now, I think it's important to see this because this lesson and the two that we're going to learn today, they call these things functions. Okay? And they give you these problems, and you might look at it and you might say, I don't know what to do here, it's a function. What is this function thing? But it's important to realize it's no different from what you've already been doing. It's just a slightly different way of writing it and different terminology. But the math is the exact same. Okay? You have an equation and you solve for something. So here they've done all this stuff. They told you x is 12 and they want to know what y is. Well, we know what to do with that. You just put x into here, 12, and you solve for y. Okay? Any questions on this?
Sorry.
Yes.
I did but different.
Okay.
Because count first the x is parent of 1
Yes.
and y parent of 2.
Y is a pattern of 2?
Yeah. So it's blank add 2 and that is 1.
Yeah, it's increasing by 2 every time.
Yeah.
Because the slope is 2. Every time you go x1, you go up 2 by y. See, there's a 2 here. So x goes up 1, y goes up 2. X goes up another 1, y goes up another 2. So you have that 2 pattern. So that's why if you wanted, you could count them. Count by 2s until you get to 12. But you can see here, you just have an equation. Right? So, and you have the x here. So you just put that x in and solve for y. That's why I'm saying, like, you know the math. And for the next 2 lessons, there's no new math. Okay? There's some new terminology, but it's the same kind of solving that you've been doing the last few weeks. Okay? So don't be intimidated by it, just sort of figure out, okay. I remember actually when I was learning this, I found functions annoying. And I'd always rewrite them as y. They had this like, you learn it, but they had this like f of x equals 2x minus 1. I was like, what is this? Let's just make it y. And then I'd solve. And I'd get it right. Now, they're trying to teach you more. It's not quite the same as an equation. But in terms of finding a solution, it pretty much is. Okay? And we'll get to that. We'll get to that. Later today. All right. Number 9. Any in between before that? You have patterns. The function's this. Solve for it. What's next in the sequence? Right? Okay, so number 9. Number 9 is pretty much the same. The same problem pretty much. Right? Here we have y equals 3x minus plus 5. Okay. And then give them the chart again. How far does it go up?
Minus 1.
Oh, it starts with minuses. Okay. X and Y. 1, 2, 3, 4. So we have minus 2, minus 1, 0, 1, and 2.
5, 8, 9.
Who wants to know 9? Okay, and it's given you these ones already?
Yeah, minus 1,
Minus 1,
2, 5,
5, 8, 11.
8, 11. Alright. So you see, Imad, these are going up by 3, right?
Yes.
Because your slope is 3. You see, this is telling you what the increase is every time. That's what a slope is, right? Rise over run.
Yes.
Every time x increases by 1, how much does it rise or drop? That's what the slope is. So every time x increases by 1, this increases by 3. If it was a negative slope, it'd be going down by 3. That's just what this is. That's why you see that pattern. But so now we need to know 9. We could count it, or we can substitute. We just solve for y. So y equals 3, x is 9. So we put 9 inside here. Plus 5. Okay, so what is 3 times 9? 27 plus 5. Okay. So what is 27 plus 5? 32. There you go. If you want, you can count it. Right? And in fact, you can look. 9 and 2, the difference is 7, right? So that means we're going up by 7. 7 times 3 is 21. So we just add 21 to this. 11 plus 21 is 32. If you wanted to do it that way, you could as well. So the slope is the main factor here. This is what's saying, like, how does it change? This is saying, where does it start? Right? What is the offset? You figure out how much it changes, and this is like the offset. Like, does it start at 5, does it start less, does it start higher? And then you just count every time how much the slope is. Because here when it's 0, here it's 5.
Yes.
Right?
Minus 1.
Alright, let's see. The next one you had a question on was number 13. You didn't have a problem with number 11? No? So we had here 1, 2nd, 3rd, 4th. I'm going to do number 11. I think it's good practice. Pardon? Oh. All right. So number 11, we have one block, right? 3 blocks,
Yes. 5 blocks.
5 blocks,
And then,
and 7 blocks.
yes,
This is first, second, third, fourth. Okay. So what is it? What are they increasing by each time? 2, right? So that means our slope is 2, right? And if this is increasing by 2 each time, right? 1 has just 1 of them, 2 has 3, 3 has 5, 4 has 7. So we want to look at, they want to know what is the 25th, right? 25th. Okay. So what it looks like is it seems like it's whatever this is, doubled minus 1. Right? So 2 doubled is 4, minus 1 is 3. 3 doubled is 6, minus 1 is 5. 4 doubled is 8, minus 1 is 7. So we double this minus 1, right? So 25 times 2 minus 1 will give us 49. Okay, you guys can figure that out. You saw the pattern, right? What is that one? D. And what I can see is if this is 25 times 2 minus 1, then basically my equation is 2x minus 1. Right? Because this is my x. So I'm saying whatever this is, 1, doubled times 2 minus 1. So that's my equation.
Teacher,
Yes.
the B is 51.
I have D as 49.
49.
Okay, you're right.
That's fine. It's fine.
No, you know what I make?
Maybe you wrote it down wrong.
I put the C, the place of
So you
B.
put C. Oh, okay. You accidentally wrote C. Yeah, it happens. It happens. Okay. Any questions on that? So you guys are fine on that. Good. Then we'll do number 13. Let me take a picture of it. I think one thing I like about this section is it's getting you to think about what's actually happening with these equations, right? What does the slope mean? What is the sort of, it's a relationship between two numbers, basically. So that's what a function really is. A function's a relationship. So it's as this one changes, how does this other one change? Alright, so 13. Price per scarf is a function of the number of scarves purchased. Okay. The table shows the price per scarf for purchases of up to 4 scarves. And now you need to find the function. Right? So let's have a look here. We have a table. This is 13 now. It has number of scarves, N, and cost per scarf, C. And we have 1, 2, 3, 4, right? And here it's 5, 4.75, 4.50, 4.25. Okay. So, what we need to do is look at a pattern, right? The first thing we look at is how is it changing between each one? How much is it changing by?
25. 0.25.
0.25? That's minus 0.5, right? So we have a minus 0.25 reduction every time. So that means that's probably our slope, right? So if this is our result, this is our x, right? So that'll be n. Because every time this changes by 1, this reduces by 25. So that's one way you can look at that and say, is there anything with minus 25n? And actually we have a lot with minus 25n. So that's not going to help us too much. Alright? But what we're looking at is we're starting at 5, right? So what we need to see is if n equals 0 here, this one would go up by 0.25, right? So let's imagine n equals 0, c would be 5.25, right? So that when n becomes 1, it gets reduced by 0.25. So if n equals 0, you have 5.25. So that means our intercept is 5.25, right? So I'm going to say this is like y, and this is like x, all right? And our intercept is x equals 0, y equals 5.25. And our slope is minus 0.25 x, so to speak. So therefore the equation is y equals minus 0.25 x plus 5.25. Okay? So this is a bit weird. We can now substitute back. But that's not what any of our equations look like, is it? However, let's see. How would I do this in a more easy way? Because what I would say here is I see like a 0.25, right? A 0.25 here. Do any of these resolve to that? So this is now we're going to put c equals minus 0.25 n plus 5.25. Okay? So let's look at A. What is A? C equals n times 5 minus 0.25. Correct. So that's going to be n. What's 5 minus 0.25? 0.75. Okay. This is not the same as that one. Let's try B. C equals 5 minus 0.25 times n minus 1. Right? That equals 5. What is 0.25 times n?
0.5.
N
What is negative 0.25 times negative 1?
Minus 0.5.
Minus and minus?
Plus 0.5.
Plus. Okay, so 5 plus 0.25. That's the same. So it's B. Okay? This is one way to do it, looking at the equations. Alright. The second way to do it is we're looking at the pattern, right? So this is 5 for when n is 1, right? So that means if we want an n of, basically we want something here that when n equals 1, we will get 5, right? So you can kind of look at this. We want something when n equals 1, c will equal 5. So we can look at these equations here, right? And we can say instead of this, we'll do similar, but we'll do like this. Straight up, A is c equals n 5 minus 0.25, right? If n equals 1, c equals 4.75. Not good, because we want n and 1 to get to 5, right? So we can try the next one, B. B is 5, sorry, let me do the whole equation. C equals 5 minus 0.25 times n minus 1, right? Now if n is 1, this is 0, and this is 5. There we go. You see that? C equals 5 minus 0.25 times 1 minus 1. 5 times 0.25 times 0, which equals 5. There we have the right combination. That's, I think, the easiest way to do it, to solve this one. And you can test the other ones too. For C, it would be 5 minus 0.25, which is 4.75, not right. And for D, it would be 5 minus 0.25 again, 4.75. So only D is giving us this correct relationship. And I chose this one because this would give me an easy one, right? I could do it for any of them, substitute it in, and see which one comes correct. How do you guys feel about that? I think there's a little bit... Not happy with it?
Because of
You want to know what I was doing here, right? You want to go over that again? I'll go over that again. Alright. So what I did is I'm looking at this thing here, right? Basically, I could easily just say, do you remember how we plot a line? Right?
yeah.
Y equals mx plus b, right? Okay, so then I say this is x, n will be x, and c will be y. Okay? And then I say, well, I have 0.1 and 5, right? And 0.2 and 4.75. I have 2 points. Do you remember how to solve the equation of a line from 2 points?
Yes.
Right? You first find the slope, which is going to be, let's make this 2 and this one 1, just for simplicity. 5 minus 4.75 over
1 minus
over
1 minus
1 minus 2,
yeah.
right?
Yeah.
So this becomes 0.725 over negative 1 is negative 0.25. Okay? Slope here. Now I figured out the slope just by looking at how they were changing, right? That's one easy way to find the slope. You just see what is the difference between them.
Yeah.
If you have them going in order, you can see the difference between them is the slope. So here we have 0.25 is the slope. So then I said, okay, now I need to solve for the intercept. Let's go here. Okay? So, to solve for the intercept, I said y equals negative 0.25 x plus b, right? And we can put this back in, right?
Yes.
So that means 5 equals negative 0.25
Times
x is
1.
1 plus b, right?
Yes.
And I add 0.25 to both sides, so b equals 5.25. That's what I got here.
Yeah.
When n is 0, 5.25.
Yes.
Or what I said was, well, I see the pattern going this way, right? It goes down by 0.25 every time. So if I just go back by 1, back to 0, it'll go up by 0.25. So that's why I did these things so quickly. I was kind of doing it in my head, just by seeing how the pattern works. But basically what I was doing in my head was this, right? The same solving the equation. But I was just looking at what's the pattern of the numbers. So now that I have these, this is my equation, I substitute my c and my n back for x and y, and then I have my equation here, and then I can see which ones look like it. But I think this is a more complicated way than just solving, just testing, right? Does that make more sense?
Yes.
Yes,
Yeah.
very.
Okay, good. Then I think it's time for us to have a break, and I'll do number 14 when we come back. Okay? Alright, so we'll do number 14. Which of the following sequences of y could be created using the function y equals 4x plus 3?
Minus
Minus 3. Minus 3. Okay. So you basically look here and you see which ones are working. So if we do A, right? You see 1, x is 1, y is 1. Fine. They're all starting with 1. But how about, you know what? What you should do is like this. Okay? So you do your table, right? X and y. Okay? We'll just do 3. We're not going to need more than that. So x equals 1, y equals 1. 4 times 1 minus 3.
Y equals 1.
Y equals 1. Okay. So let's do that. 1 goes to 1. 2 is 4 times 2 minus 3. What does that become? What's 4 times 2?
5. 8
Eight.
minus 3. 8.
So it's 8 minus 3?
5.
5. Okay, let's try 3. 4 times 3 minus 3.
9.
Alright.
9.
12 minus 3?
9.
9. And so on. But I think we can find the pattern, right?
Yeah.
1, 5. Oh, already, just B.
B.
Like that. Do you see how I did it?
Yes.
I said basically I'm just taking every x, what is y for each one, and then you see the pattern coming.
Minus.
Right? And I just did x is 1, x is 2, x is 3. I could have kept going 4, 5, 6, 7, etc. And I would get them. Because this is what a function is doing. It's putting it in here. Okay? So this is kind of like why they say f of x equals 4x minus 3. So then f of 1 equals 4, 1 minus 3. F of 2 equals 4, 2 minus 3. F of 3 equals 4, 3 minus 3. You see that? Like whatever x is, you're solving the function of it. And we're going to get into that today. Okay, this way of writing it.
It's clear now.
Yeah.
Because in this case, if I use x equals 0, it's going to give me minus 3.
Minus 3. Hmm? Yeah. So f of 0 equals 4 times 0 minus 3.
Yeah.
Right? Whatever x is, you put it in. So this is like y. F of x is like y. This is what a function is. It's a function of this is the relationship, and then for every x we can solve what the relationship will be. Okay. Any questions on that? Good. This is a good introduction to our next lesson. I'm going to keep this up. Because this is what's called function notation. Okay? These kind of go together anyway. So, let's not do review. I'm done with review now. So function notation is a way of writing an equation as a function of x. Alright? So you say a function of x, f of x, equals some relationship. Well, we're doing function notation. I'm doing it all together, so it's fine. It's the next lesson, but this one on number 12 is basically just practice. Yeah, so function notation is basically f of x equals some relationship of x, right? So it can be anything. It could be x squared minus 2. You can have f of x equals negative 3x plus 1 over 2, like any format, as a function of x. And what you're looking at is, it's saying for every x, this is the outcome, right? So like we did here, we're saying what is, if x is 1, what is the function of x? What does the relationship come out to? Now this is kind of the same as saying y equals x squared minus 2, or y equals minus 3x plus 1 over 2. But what you get with functional notation is you really can see how it's representing the relationship of how x is changing, the function is changing, right? So functions are often used for, say, like for finance, for money. So you can have like a function of a interest payments or something like that. So you can say f of x equals, you know, $2,000 minus 50x or something like that. Right, so you have an initial 2,000 payment, and it reduces every time, like maybe x is a day. So we could do f of d instead of x. Right? So you're wanting to know how payments change over how many days you've been doing something, right? And so then you say the function of that, how they change, is every day it's 2,000 minus 50 less than 2,000. This is just an example of how this can be. So this is what the function is. We basically have this relationship of how d changes, the whole thing changes. So what we have when we do like applications is basically, it's a way of kind of using word problems. We're using functions to describe word problems. Okay? So, say for example, you have this sort of, they talk about this problem here. This is now page 380. They say, Celino Advertising is finishing a series of print ads for a client. Finishing the project will cost $2,000 per day for the first 7 days, and $3,500 per day after 7 days. And then they say, here's a function to find out the cost overall. And they say C equals,
I forget my phone.
that's okay, 2,000D plus 1,500 times D minus 7. So they say this is a function. But you could also write this as a function of D equals 2,000. Is it D or just 2,000? It's 2,000D, yeah. Okay? And then what you're looking at is, depending on how many days, how days change, you can see how the total cost changes, right? So as days increase, the cost increases. Now it says the first 7 days. So we're going to assume it's going to take more than 7 days, right? So then it says, if the project takes 12 days to complete, what will the project cost? So therefore, it's essentially this solving for if D equals 12, what does C equal? Okay? Which is the same kind of thing we've been doing already. It's solving an equation. Substitute the variable in, solve for the other variable. Right? That's basically what you're doing here. So don't let the way it's set up as a word problem or the strange appearance of the function throw you off. It's the same kind of math. They're telling you what D equals, you need to solve for C. Right? So we just solve it. So we could say C equals 2,000, now D is 12 times D, right? Plus 1,500 times 12 minus 7. Right, and we solve for C. So what is 2,000 times 12?
24,000.
24,000, right? And I'll write it the American way, with a comma. Okay, 24,000. What is 1,500 times 12? 18,000. So if you want to do it, you can say 12 is 2 times 6, right? So instead we'll do 3,000 times 6. Because if we look at it, it's 1,500, right, times 12. That equals 1,500 times 2 times 6, right? This is if you're doing it in your head, which equals 3,000 times 6. Now that one you can do in your head, right?
No.
18. So plus 18,000. And what's 15? You know, what am I doing? I did not do the rule. PEMDAS. PEMDAS. Brackets first. Parentheses first. 200. What is 12 minus 7?
10,500.
5.
Oh.
That's a lot easier, isn't it?
Oh, yes.
This is why they
Yes.
tell you to do this rule. Okay, so that's going to equal 24,000, right? Plus, what's 1,500 times 5? 7,500. Okay, 24,000 plus 7,500?
21.
What's 24 plus 7? You're close, not 20 though. 31. 31,500. That's right. 31,500. There we go. So, in 12 days, the cost will be 31,500. Okay? If you were to write it as functional notation, what we would do is f of 12 equals 12,000 and 2,000 times 12 plus 1,500 times 12 minus 7. I would solve the same way, right? That would end up being also 31,500. Okay? So the functional notation is basically just the same as this. It's just, it makes it actually almost easier to see what's happening. Because you're putting the number, d is here as a variable. Here you do the number and you're solving out what it is. Any questions on this? It's clear? Okay. Take a picture of it. There you go. Now, there's something else with functions. And this is something called the domain and the range. So functions have a limit. They only apply for a certain set of numbers. And that's one way that they are different somewhat from equations. Because equations are almost always open-ended. But for a function, often you have to look at the problem and figure out what is the range of numbers that it works for. Because very often, you can't have a negative number in a function. For example, when we were doing the cost as a function of days, you couldn't have a negative d, right? Because you can't have negative days of work, right? So technically, by the math, yeah, you could put a negative number in for d. For sure, you could do that. But in terms of the actual problem for the function, you can't have a negative number for d. So the domain is the limit of the variable, okay? And the range is basically how far the function can go with the limit of the domain. So let me show you some examples, okay? So say for example, say we have this one, f of x. F of x equals 4x minus 3, okay? And say now, this is like a function of days or something, right? So we'll do d. F of d equals 4d minus 3. So we know a day has to be greater than 0, right? So actually the domain for this function is that d is greater than 0. That's the domain. Right, that's the limit on this function, because a day cannot be a negative number. And maybe it has to be greater than 1 sometimes. Right? Greater than or equal to 1, you could say. Right? You have to have at least 1 day of work. Right? So the domain is greater than or equal to 1. Now the range is basically what is f of the domain. Alright? So f of 1 equals 4 times 1 minus 3. Right? You agree with me on this?
Yes.
Going from here? So f of 1
This one.
equals 4 minus 3 equals 1. So actually in this case, the range is also f of d is greater than or equal to 1. So d is greater than or equal to 1, and the function of d is greater than or equal to 1. Right? In some ways this is a bit confusing here. So let's take the example we had before, right? And that was f of d equals 2000 d plus 1500 times d minus 7. Right? That was the function. Now in this case, the first 7 days were set, and then you're seeing how many days after 1 week. So that means that we can't be less than 1 week, right? Days have to be 7. Has to be more than 7. So that means our domain is that our days are greater than 7. Right? Because we can't have less days than a week, because it's starting from 1 week. So our domain is days are greater than 7. Days are greater than 7. So then the range is going to be f of d. The range will be f of d greater than 7, basically. Right? So we solve for that. So for this, let's just do the d equals 7. And the range will be whatever that plus and greater. Alright, so what is f of 7? 2000 times 7 plus 1500 times 7 minus 7. Right? Okay, so this one's nice and easy. First of all, what's 2000 times 7?
14,000.
14,000, right? And what's 7 minus 7? 0. 0 times 1500?
0.
So it's just 14,000. Alright? So f of 7 is 14 and 14,000. So therefore, f of d greater than 7 is going to be greater than 14,000. Right? So that means our range is basically greater than 14,000. Or you can say f of d range, just like domain, so I put them together. We say domain is d greater than 7. Range is f of d greater than 14,000. Do you see that? This is how domain and range work. So what you have to do, the challenge I think in these problems is actually figuring out the domain. Because once you have the domain, you just put it into the equation to find the range. Alright, because it's usually like greater than or less than some number. So you put that number into the equation, and then the range is greater than or less than that number. Right, like here was greater than 7, so I solved for 7, and then the range is greater than that solution. Okay? So say for example, we have something like, they give you one of these again. Y equals 3 over x plus 1. Okay. So then they say, well, what is the domain of this equation? It is possible for the domain to be all numbers. Right? You can't say the domain is all numbers. But in this case, there is one specific number where we have a problem. Right? What is that number?
3.
3.
3? If x equals 3,
2.
it's fine. If x equals 3,
1.
if x equals 1, it's going to be 3 over 2. If x equals 0, it's going to be 3 over 1, or 3. What happens when x equals minus 1?
0.
We have a 0 underneath, right? This is a problem. We can't divide by 0. Right?
Divided by x.
Pardon?
Divided by x.
Well, you're dividing by x here.
-1.
But if x equals minus 1, we have a problem.
Y equals 0.
Y doesn't work. Y equals infinity. Y equals undefined. You're not allowed to divide by 0. So that means x, I'm going to put like not equal 1. Minus 1, right?
-1, yes.
X cannot equal minus 1. So you can say the domain all numbers, yeah, except minus 1. Okay, so if that's the case, what is the range?
All numbers bigger than -1.
So we put minus 1 in here, we're going to have a problem, right? Right? However, what we can do is, if we're getting close to it, right? So, basically, the range is going to be all numbers. Because, let's say we put x is minus 0.9, right? Then y equals 3 over 0.1, which equals 30. If x equals 0.09, y equals 3 over 0.01, which equals 300. Right? If x equals, negative 99. X equals negative 99. Y equals 3 over 0.01. X equals negative 0.999. See, we're getting closer and closer to minus 1, right? Then y will equal 3 over 0.001, right? Because it's 1 plus this. And then that'll equal 3,000. Do you see what's happening? As we're getting closer to minus 1, y is getting bigger and bigger. Right? So the closer we get to minus 1, the bigger y gets. So it's just basically y is tending towards infinity as x gets close to minus 1. But what that means is y basically can be all numbers. So let's say the range all numbers. Because there actually isn't anything that y cannot be. So domain is all numbers except minus 1. Range is all numbers. Let me take a picture of that. You guys still thinking about it? Yeah?
No.
Let's try another
We
example.
need more, yeah?
Yeah, let's do another example. Okay. Alright, so say for example, let's see. Let me just write again, domain and range. Let me define them for you. Set of values, what is it? Set of values for which the function is defined or makes sense. Okay? The range is the set of outcomes I should say possible outcomes. Okay? So this is D. That's all possible D. This is all possible F of D. Okay? So domain is a set of values for which the function is defined or makes sense. So a set of whatever this number can be. Alright, in your function. Range is a set of outcomes or results of function that are possible. So that's whatever the whole thing can do. Right? So domain is whatever this value can be, and range is whatever the whole thing can be, like when you sort it through. So let's take for another example. Let's say we do f of x equals x squared. Okay? What is the domain of this? What are the possible values of x here?
Unknown.
Unknown?
If x is wrong.
Are there any numbers x cannot be? That would like make it undefined or make no sense?
It's all numbers.
All numbers.
Yes.
So the domain here, oops, all numbers. We actually have a way of writing that. We can say like this, it's a double R, which means all real numbers. Okay? How about the range?
So a number is squared.
Pardon?
Is any number squared, right?
Any number squared? Can f of x ever be a negative number? How would you get f of x negative? For what x will f of x be negative?
By negative number.
Alright? Let's try that. F of negative 2 equals negative 2 squared, which equals 4. I can't get it to be negative. Do you see that? For this f of x equals x squared, there is no number I can put in here that will get my outcome to be negative,
All
less than
positive
0,
numbers.
right? So it's all positive numbers. So the range, I'll put a question mark here, range is basically f of x is greater than or equal to 0. Right, it's all numbers greater, because if x is 0, it'll be 0. So it is also equal to. But it's going to be greater than 0. Can you see that? Domain could be all numbers, but the range is whatever this can be. And it can't be 0. And it can't be lower than 0. It can't be a negative. It would be the same if I gave you this. F of x equals absolute value of x minus 3. Okay? Do you remember absolute value?
Yes.
Yes.
What does absolute value do?
It's X.
It always makes it positive, right?
Yeah, one is
Yeah.
positive.
If
Okay.
it's negative, it's positive.
Yeah, if it's negative, it's positive. If it's positive,
It's
Negative.
positive.
it's also positive.
Yeah.
It's also positive. Okay. So, the domain, again, because there's no dividing by 0, right? And there's no math problem that says it has to be like, it's days, so it can't be negative. So the domain, again, is all numbers. The tricky thing now is the range, right? So we have to see, what is the limit? So if x is 0, what is f of x?
-3.
F of 0 equals absolute value of 0 minus 3, which equals -3. Is there any way we can get lower than -3? Because any negative will become positive again, right? So if you have -1, it'll be 1 minus 3, which is 2, or minus 2. So the -3 is actually the lowest we can go, right? So that means the range is f of x is greater than or equal to -3. Do you see that? You're getting it? You're kind of seeing how it works? I'll give you another example. Let's take a picture. F of, well, I'll just do one. Somehow they just put them as y's and x's, so we'll do that too. Y equals negative x squared plus 7. Okay. What is the domain?
X squared.
Domain is what can x be. Okay. So domain. Are there any numbers that's a problem?
X squared.
Pardon?
Square.
-1 is
So what numbers, are there any numbers x cannot be?
8. 0.
If x is 0, y is 7.
Y is
That's
7.
fine.
-7.
X is -7, it's -7 squared, becomes 49, negative 49 plus 7 is negative 35.
Positive 7.
Positive 7. Negative 49, it'll be the same. Negative 35. So any number of x we can use, right?
Yes.
So I'm going to do this again. You know what that means now?
All real numbers.
All real numbers. Okay? Range. Is there any number that y couldn't end up being?
All numbers.
All numbers?
No.
No.
What range?
What if x equals 1?
It is.
X equals 1
It is 8.
becomes negative 1 plus 7
8.
becomes 6.
6.
6.
Oh,
Right?
yes.
What if x equals negative 1?
8.
Negative 1 squared becomes 1.
1.
Minus 1 plus 7, also 6.
6.
What if x is negative 100? Right? It's very negative, right?
Yes.
It'll be 100 squared, which is 10,000. Negative 100 squared minus 7 is still a big negative number. What if x equals 0?
0.
7.
It's 7.
Yeah.
Is there any way we can get it higher than 7? Is there any way we can get y higher than 7?
If x is 2.
If x is 2, it'll be 2 squared, becomes 4.
11.
Negative 4 plus 7 is
11.
3.
Yes.
It's negative 4. There's a negative in front of it.
3.
So whatever this is, it's going to become negative.
Is
Whatever
it-
x is, it'll be a negative.
Negative is not including the number.
No. It's negative x squared. X is then going to be in brackets,
Ah, okay.
Yes.
right?
So here we can use 4.
4
It's 3.
will become 4 squared is 16.
Yeah.
So it's negative 16 plus 7 is negative 9. It's always pushing lower.
5 is okay.
Whatever number you put in there, it's going to be either negative or below 7.
No, here I still have a problem with this
Negative 5.
negative x squared.
Okay?
In this case, is it possible x to be yes
Like this.
like this one?
But when we write x squared, this is what we mean. Negative x squared plus 7. If x equals 4, I put y equals negative 4 squared. Oops, plus 7, right? That's how I translate this one to here. The negative doesn't go inside.
Okay.
So whatever you're putting in here, positive or negative, it's going to square and it'll become, this one will be positive, so this one will be negative. You see that? It's the flip side of the x squared one. X squared couldn't be lower than 0, right? Negative x squared can't be greater than 0. So that means if it's negative x squared can't be greater than 0, the whole thing can't be greater than 7. So the range is y is less than or equal to 7. You guys see that? I'll do another one. We have a little time, so do more examples. Think, yeah. This is part of the picture from before.
If x is x cubed.
Pardon? X cubed.
Yeah.
Let's do it. F of x equals 3x cubed plus 2. Okay. X can be anything here because we're not dividing by x. Right? So it's fine. So domain, again, reals. Okay. Range. First I'm going to do f of 0, right? F of 0 equals 2. Okay. So here we have a 2. We want to see, can we get higher than 2 or lower than 2? Is it possible? F of, let's say, negative 1 equals 3 times negative 1 cubed plus 2, right? Which equals what's negative 1 cubed?
Is negative 1.
Right? Because 1, 2, 3.
Yes.
Right? It stays negative. So that becomes 3 times minus 1
Minus 1.
plus 2,
Minus
which is
1.
negative 3 plus 2, which equals negative 1. Alright. How about f of 1? 3 times 1 cubed plus 2,
5.
right? So that's going to become 1. So that'll be 3 plus 2 equals 5. Okay. So this one is less than 2 and it's minus 1. This one's greater than 2 and it's 5. So it looks like as we get x more minus, the function gets more minus. As x gets more plus, the function gets more plus. So when it's a cube, it's all numbers. So the range is also all reals. That's because you can get either sign. Whatever sign comes in here, it's going to come out here because it's an odd number. It's only the even ones that'll mess things up. Right? Or an absolute value. Or you're dividing by x. Or something like that. You can have more complex ones, which I don't think the GED will go into. But you could have something like this, and don't be alarmed. It's a bit, this is hard. But say we have x equals 2 to the power of x. Right? So then we can say function of 0 is 2 to the power of 0, which equals 1. Right? Function of 1 equals 2 to the power of 1, which equals 2. Function of minus 1 equals 2 to the power of minus 1, which equals 1 over 2. Right? function of minus 2 equals 2 to the power of minus 2, which equals 1 over 4. So it looks like it's going to go up and down, but it's never going to be greater than 0. Or less than 0, right? So then I would say domain all reals, range f of x is going to be greater than 0. It'll never get to 0. Because for it to get to 0, x would have to be infinity. So it's not going to be equal, it's greater than. So I don't think you're going to have a problem like this, because we didn't do open-ended exponents, right? We just did squares and cubes. But I'm happy to teach it to you. This is an example. It works for every kind of equation. Wherever x is, you can actually find a domain and a range for it. For the GED, it's a bit easier problems you'll get, but as you do more math, you'll see things like this as well. And the principle's the same. The domain and the range are the same. Are there questions on this? It's a pretty cool concept, actually, if you think about it. You learn it. Yeah, examples, right? Practice. Okay, that's it. And this is the end of algebra.
Okay.
All right? Next week we start geometry.
Uh,
All right? And that's the final section.
Final.
So, good job. You just did algebra. You just finished algebra. Well done. All right, have a good week. The homework
sure,
is
what
page...
range?
Pardon?
The range. The last one.
Yes. Oh, it's... Sorry. This looks funny. F of x is greater than 0. Yeah. And the homework is going to be page 381. I think it's 381.
Yes.
Oh no, 371. 381 and 383. All and page 383. All. All right. Good luck.
Thank you.
Okay.